For our third shape in the series, we're going to be talking about something called hyperbolas. Okay, so fancy new shape we're going to learn today. And let's start it off again with the general form equation. So hyperbolas will look like this: x minus h squared over a squared, y minus k squared over b squared equals 1. So basically that looks exactly the same as an ellipse would, so the only difference going to be is that there's a minus sign in between. So it's two fractions set equal to 0, but they're going to be subtracted. That's the difference between hyperbolas, subtraction, and ellipses with a plus sign in between. The same thing's going to be pretty similar for the way we set this up. All right, h and k are going to give us the vertex. A and b are going to give us the, well, A is going to give us the horizontal distance, B is going to give us the vertical distance. So I'm actually going to start showing us a general graph of this. No numbers, just give us those distances here. So here's how we're going to do it. H and K are going to give us the center, and let's just put that center right here in the middle of the graph. That's fine and dandy. The A distance, is side to side. So let's say we went out about this far and about this far. Okay, so that distance there and that distance there are the same distance, both called A. The up and down distance is B, and let's say we went to about there and there. There's B, and there's B. Okay, so far it's just the same as an ellipse. But instead of connecting those points and drawing an oval, what we're going to actually do is, from these points, create a rectangle or a box that goes through these. Okay, so we do have points here to represent the A's and the B's. We're going to go through these points, creating a box. Okay. The reason we draw this box is because now through the corners and through the center, we're going to draw these diagonals, and these are going to be asymptotes. So through the center, out the corner, out the corners, through the center, out the other way, we've created these asymptotes. We created an X here. Now these are just guiding us on how to make the shape. These actually aren't the shape just yet. The actual shape, and I'm going to put this in highlighted pink, the actual shapes are these curves. So we're going to go close to the asymptotes, going through this point here. So we're going to hug the asymptotes, hit that point, and then back out. And they'll continue off. We're also going to have one on the other side. Looks like this. So if we were to take away all the guidelines, the X's, the box, everything else, basically the hyperbola shape are just those two pink curves on the sides. These are hyperbolas. Now the one thing I want you to note, this shape goes with that equation above. All right? And I want you to notice something. When X comes first, we're going to have hyperbolas that go side to side. Because you notice, because of the minus sign, if we were to switch the order, it would be a whole different equation. So when X is first, I'm going to make the note up here. When X is first, we're going to have the side-to-side hyperbolas. So I'm going to redraw this whole equation again because there's a second set. Let's say we were to have y minus k squared over b squared, because remember b, k, and y all go together, minus x minus h squared over a squared equals 1. That's a very different equation, okay? Now y is first, minus x second. So make a note of that. This one is y first. This is going to make a graph where the hyperbolas are up and down. So again, I'll draw that real quick. So depending on the numbers, they're not always going to be centered at the origin, but it'll still have that same distance. All right, so let's just say, I'm going to make it quick without the letters. We would have a box. Go through the center, out the corners, but this time your hyperbolas would be above because of the y first. All right, so if y is first, it's up and down. If x is first, it's side to side. So something just to note on that. So now the order is very important for the equations we're going to look at. So let's remember that as we start with our first example here. So example number 1, again, graph x minus y squared, or x minus 3 squared over 25 minus y plus 4 squared over 4 equals 1. Okay, so maybe the first thing to do is just identify which way my shape's going to go in the end. We look, and what comes first is the x. X first means it's going to be a side to side, so just keeping that noted for later, okay? Because everything, the whole process is going to be the same, just at the end we want them to go side to side and not up and down. All right, we're going to find our starting point, our center, our vertex is again given by hk. H being connected to x, k being connected to y, so I see a -3, I'm going to write +3. I see a +4, I'm going to write -4. We want A and we want B. A, remember, is side to side. B is up and down. A usually goes with x and B goes with y. So A is going to be this number here, but take the square root. Square root of 25 is 5. B is going to be this number here connected to the y. We take the square root of it, it is 2. And we have everything we need now to graph. So fairly large graph just because there's a lot going on here. I'm going to redraw that because this is okay. We have the x-axis, we've got the y-axis. All right, let's put the center. Center is at 3, -4. So over 3, down 1, 2, 3, 4. So center right there. Okay, that's the center. From there, just like we did the ellipse, let's go ahead and count out the side to side and the up and down. So I need 5 side to side. So 1, 2, 3, 4. We need one more over here, 5. 1, 2, 3, 4, 5 this way. Put it somewhere around there. Okay, there's the side to side distance. I'll mark it out for you this time. We went 5 and we went 5. We're also going to go up and down. Up 2, down 2. Distance of 2, distance of 2. Now we're not connecting them this time with an ellipse. We want to go ahead and make the box out of this. All right. Okay. All right. From the box, we're going to draw the diagonals. All right, so through the corner, from the corner, through the center, out the other corner. I can do better. If you miss, it's okay. I get the general idea. There we go. Okay. Now these are all our guidelines. Now the last thing I'm going to do is look back up here. We said it's going to be side to side because of x first. So hug the asymptotes, hit this point, and then back out. Draw arrows because it continues. Same thing over here. Hug the asymptotes, hit the point, and then back out. And there we have our hyperbolas. So depending on the numbers, these things can get skinnier, they can get wider. Obviously some will go up, some will go down. But it all depends on the equation they give us. So let's take a look at another one. For example, graph y minus 2 squared over 25 minus x squared over 4 equals 1. So just looking at this right off the bat, two sets of fractions, subtraction. It's going to be hyperbola, but it's y first. That means my hyperbola shapes are going to be up and down this time. let's go ahead and get to work on it. The vertex, or I guess we can call it the center, is made up of HK. But we got to be careful. H is the one connected to X. K is connected to Y. So this is the K. The H is somewhere over here. So K, positive 2, gets written second. H, there's no number connected to the X, so that's going to be a 0. 0, 2. A value, B value. Again, we've got to be careful. A goes with the X, so A is over here. B is the first one now. So square root of 4 is 2. That's my A. That's my side to side. B is my up and down. Square root of 25 is 5. And there's all the info we need to graph it. Okay. All right, we got our X, we got our Y. Our center is at 0, 2, so 0, 2 is right here. It's my center. And then we'll count out 2 to the sides, 5 up and down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Make your box connecting all these together. All right, from the box, we put our diagonals, put our crossing lines through here. And remember, we got to draw our shape now. These are all guidelines. The actual shapes are the last things we put on, and we've marked them that we're going to be up and down. So hug the diagonals, hit the points, hug it, and back out. Same thing on the bottom. Alright, so just the pink parts are the actual graph, the hyperbolas. Again, they'll move around, they'll change shape, they'll change size, all depending on the equation that we give it. Alright, so the big thing to remember here is X comes first, it's side to side, Y comes first, up and down.